Next, we can see the ionic size trend in the periodic table. So, let us have a very quick review on the formation of ions. An atom that has either lost or gained one or more electron, it forms ion. So gaining electron means more negative than positive charges. So the ion is negative. Losing electron means more positive compared to the remaining electrons. So the ion will be positive. Ionic radius has the same trend as the atomic radius. It depends on the nuclear charge, the number of electron, and the subshell it resides. That means if whether it is in s orbital or in the p subshell. So we can see that when you see that periodic table into two sections, metal section and the non-metal section. So we can see that metal form cations. The cation size decreases from left to right, and the anion size decreases from left to right. And along a group that is from top to bottom, in both cases, the size increases. Also notice the size of the ion. Lithium ion is smaller than lithium atom, and sodium ion is smaller than sodium atom. Potassium ion is smaller than potassium atom. And when you look at the anions are bigger than the corresponding neutral atom. Fluoride ion is bigger than fluorine atom, and chloride ion is bigger than chlorine atom, and bromide ion is bigger than bromine atom. This is because when lithium atom forms a lithium ion, we can see the electron configuration changes from 2, 1 to 2. That means we don't have the outer shell in the lithium ion here. So that means one outer shell is getting removed. So the electrons are more closer to the nucleus, more attraction, so the size decreases. So look at sodium atom here. The electron configuration is 2, 8, 1. And for the sodium ion, the electron configuration is 2, 8. So we don't have the outer shell here either, right? So that is removed. So the electrons are now more closer to the nucleus, so more attraction, so the size decreases. And now let us see in the case of anions, when the fluorine atom changes to fluoride ion, we can see the electron configuration changes from 2, 7 changes to 2, 8. That means one electron is added. So that means there will be more electron-electron repulsion that causes fluoride ion size bigger than the corresponding neutral fluorine atom. Same explanation for chlorine atom. So chlorine atom electron configuration is 2, 8, 7. And for chloride ion, it changes to 2, 8, 8 because one electron is being added. So there will be electron-electron repulsion. So that causes the chloride ion bigger than the corresponding neutral atom, which is chlorine atom. So in conclusion, both atomic and ionic size increases going down the group. The reason for that one is moving down the group, the principal energy level increases. Both for atoms, neutral atoms, as well as for ions, both anions and cations. And going across a period, the ionic size first decreases and then jumps up when oxidation state changes from positive to negative. That means when metal to non-metal change happens. So after the jump, the downward trend in size continues. That means from left to right, the size decreases. Apart from the general trend, we can have ions with the same number of electrons like here. Oxygen can form an oxide ion with 10 electrons. Fluoride ion also has 10 electrons. Sodium ion also has 10 electrons. In all these cases, we can see the nuclear charge is different, even though the same number of electrons. Oxide ion will have 8 protons. Fluoride ion will have 9 proton, and sodium will have 11 proton. Magnesium will have 12 proton, and aluminum 13 proton. So the nuclear pool will increase and the size decrease.